Tell me about a time you worked on microservices introduction. This is a very common behavioral and technical interview question for Java developers, backend developers, senior developers, and full-stack developers. Interviewers ask this question to understand how much real microservices experience you have, how you design service boundaries, how services communicate with each other, how you handle failures between services, how you manage databases in microservices, how you secure service-to-service communication, how you monitor and troubleshoot distributed systems. Catch: how you think about scalability and maintainability. This question is especially important for Java developers, backend developers, Spring Boot developers, full-stack developers, senior software developers, cloud developers, team leads, system design interviews. The best way to answer this question is by using the STAR method. STAR means S. Situation. Explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result. Explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand what you actually did in the microservices system. Question: tell me about a time you worked on microservices. Example 1, building a new Spring Boot microservice situation. In one project, our team needed to add a new business capability to an existing platform. The existing application was moving toward a microservices architecture, and the new feature needed to be built as a separate Spring Boot service. Task: I was responsible for designing and implementing the new microservice, including REST APIs, service logic, database access, validation, error handling, and integration with other services. Action: I started by understanding the business capability and defining the service boundary. I made sure the new microservice had a clear responsibility instead of mixing multiple business domains. Then I designed the main REST APIs for the service. I defined endpoint URLs, request DTOs, response DTOs, validation rules, error response format, database tables, service layer logic, repository layer logic. I used Spring Boot with a layered structure. Controller layer for REST APIs, service layer for business logic, repository layer for database access, mapper layer for DTO conversion, exception handler for standard error responses. I also added logging with correlation IDs, so requests could be traced across services. For integration, the service called another internal service using a REST client. I added timeout configuration, error handling, and fallback behavior for downstream failures. I also wrote unit tests and integration tests before handing the service to QA. Result: the microservice was delivered successfully and integrated with the existing platform. The clear service boundary made the feature easier to maintain. The standardized API and error handling made front-end and downstream integration smoother. Why this answer works? This answer is strong because it shows: check. Spring Boot microservice experience, service boundary design, REST API design, layered architecture, validation and error handling, service integration, testing. Example 2. Microservices communication using Kafka situation. In one backend system, a user action triggered several downstream updates. Initially, the flow used synchronous REST calls between services, which made the user-facing API slow and dependent on downstream services. Task: I was responsible for helping improve the microservices communication flow so downstream processing could happen asynchronously. Action: I started by mapping the existing service communication flow. I identified which operations needed to happen immediately and which operations could happen later. I found that some downstream updates did not need to block the user response. So I helped design an event-driven flow using Kafka. The flow was then user action down. Main service validates and saves core data. Main service publishes event to Kafka. Consumer services process downstream updates asynchronously. I helped define the event payload with. Check. Event ID, event type, timestamp, business identifier, source service, payload version. To make the flow reliable, I added correct idempotent consumer processing, correct retry handling, dead letter queue, correct duplicate message handling, correct audit logging, correct monitoring for consumer lag, alerts for failed messages. I also worked with QA to test normal messages, duplicate messages, invalid messages, retry scenarios, and downstream service failures. Result: the user-facing API became faster because it no longer waited for downstream systems. The microservices were more loosely coupled. Downstream failures could be retried safely without affecting the main request. The same event-driven pattern was later reused for other flows. Why this answer works? This answer is strong because it shows Kafka experience, asynchronous microservices communication, loose coupling, idempotency, retry handling, dead letter queue, distributed system reliability. Example 3. Splitting a monolithic module into a microservice situation. In one application, a large module had grown inside a monolithic system. The module had its own business rules, database tables, and release needs, but it was tightly coupled with the rest of the application. Task: I was responsible for helping analyze the module and contributing to the migration plan to separate it into a microservice safely. Action: I started by reviewing the module boundaries. I identified business capabilities, database tables used by the module, APIs used by other modules, shared utilities, external dependencies, transaction boundaries, data ownership, deployment dependencies. Instead of extracting everything at once, we chose an incremental migration approach. First, we created clear APIs around the module inside the monolith. Then we reduced direct database access from other parts of the application. After that, we moved the business logic into a new Spring Boot microservice. We defined the new service as the owner of its data and exposed APIs for other services to interact with it. We also added API contracts, service-level tests, database migration scripts, backward compatibility during transition, monitoring dashboards, rollback plan. Result: the module was gradually separated into a microservice with reduced risk. The new service could be deployed independently. The code became easier to maintain because the business capability had a clearer ownership boundary. Why this answer works? This answer is strong because it shows check monolith to microservice migration, service boundary analysis, incremental migration, data ownership, backward compatibility, deployment independence. Example 4. Handling failure between microservices situation. In one microservices-based application, our service depended on another internal service for customer verification. During peak traffic, the downstream service became slow, which caused our API response time to increase, and sometimes timeout. Task: I was responsible for improving the reliability of our service when downstream services were slow or unavailable. Action: I started by reviewing logs, response time metrics, and distributed traces. I found that our service waited too long for the downstream response. When the downstream service was slow, our request threads were blocked, affecting other users as well. To improve resilience, I updated the integration design. I added cock timeout configuration, retry only for safe retriable failures, circuit breaker pattern, fallback response where appropriate, better error handling, monitoring for downstream latency, alerts for failure spikes. I also made sure retries did not cause duplicate processing. For operations that could happen later, I recommended moving them to asynchronous processing instead of blocking the user request. Result: our service became more stable during downstream slowdowns. Timeout-related failures decreased. The system handled downstream issues more gracefully, and users received clearer responses instead of random failures. Why this answer works? This answer is good because it shows 1. Microservice resilience, timeout handling, retry strategy, circuit breaker pattern, distributed tracing, production reliability. Example 5. Database ownership in microservices situation. In one project, multiple services were accessing the same database tables directly. This made the system difficult to maintain because changes in one service could break another service. Task. I was responsible for helping improve the data access pattern and move toward better microservice database ownership. Action. I started by identifying which services were reading or writing the same tables. I documented table ownership, read patterns, write patterns, shared queries, business roles, data consistency requirements. Then I worked with the team to define clear ownership. One service became the owner of the core business data. Other services stopped directly updating that data and instead used APIs or events to request changes. For read-only use cases, we discussed safer options such as API calls, events to maintain local read models, reporting views, controlled data replication, summary tables. I also helped update documentation so developers understood which service owned which data. Result. The architecture became cleaner because data ownership was clearer. Database changes became less risky. Teams had a better understanding of service boundaries and avoided direct cross-service table updates. Why this answer works? This answer is strong because it shows database ownership, service boundaries, reducing coupling, data consistency thinking, microservice architecture maturity. Example 6. Securing microservices situation. In one microservices project, we needed to secure APIs so only authorized users and services could access protected resources. Some APIs were public within the internal network, but they still needed proper authentication and authorization. Task. I was responsible for implementing security checks for new APIs and making sure service access followed the required standards. Action. I started by reviewing the existing authentication and authorization pattern. The system used token-based security, and each request included user identity and roles. I added security rules to protect the new endpoints. I implemented cost, authentication checks, role-based authorization, token validation, request validation, secure error responses, audit logging, protection for sensitive endpoints. For service-to-service communication, I made sure internal calls included required security headers or service credentials, according to the team standard. I also tested valid token, missing token, expired token, invalid token, user without required role, service access scenarios. Result. The microservice APIs were secured successfully. Unauthorized access was blocked. The automated security tests improved confidence for future changes. Why this answer works? This answer is good because it shows check, microservice security, check, authentication, check, role-based access, check, token validation, check, service-to-service security, audit logging. Example 7. Monitoring and troubleshooting microservices situation. In a microservices environment, users reported intermittent slowness. The issue was difficult because a single user request passed through multiple services. Task. I was responsible for helping trace the request path and identify where the delay was happening. Action. I started by using correlation IDs to trace one request across multiple services. I reviewed key API gateway logs, service logs, response time metrics, distributed traces, database query timing, downstream dependency timing, error rates. After comparing fast and slow requests, I found that the delay was happening in one downstream service call. That downstream service was slow because one of its database queries was performing a full table scan. I worked with that team to review the query execution plan and add the correct index. I also helped improve dashboards so we could see latency by service and dependency. Result. The root cause was identified and fixed. Overall, request latency improved. The improved monitoring made future cross-service troubleshooting faster. Why this answer works? This answer is strong because it shows distributed tracing, correlation IDs, cross-service debugging, monitoring dashboards, Database bottleneck analysis. Production troubleshooting. Example 8. Deploying microservices with CI/CD situation. In one project, microservice deployments were taking too long because several manual steps were required. This increased the risk of deployment mistakes and slowed down releases. I was responsible for helping improve the deployment process for one Spring Boot microservice. Action. I started by reviewing the existing deployment process. I identified repeated manual steps such as X. Building the application. X. Running tests. Creating deployment artifacts. X. Updating configuration. X. Deploying to environment. X. Checking logs. X. Verifying health endpoint. I worked with the DevOps team to improve the CI/CD pipeline. The pipeline included copy, automated build, unit test execution, integration test execution, artifact creation, environment-specific configuration, deployment step, health check validation, rollback support. I also added a health check endpoint and improved application startup logs, so deployment verification was easier. Result: deployment became faster and more reliable. Manual deployment mistakes decreased. The team had more confidence releasing changes to the microservice. Why this answer works? This answer is good because it shows CI/CD experience, microservice deployment, automation, health checks, release reliability, collaboration with DevOps. Best short answer version. If you need a short interview answer, you can say, in one project, I worked on a Spring Boot microservice that handled a new business capability. The existing platform was moving toward microservices, and this feature needed to be built as a separate service. I was responsible for designing and implementing the service, including REST APIs, database access, validation, error handling, and integration with another internal service. I started by defining a clear service boundary, so the microservice had one main responsibility. Then, I designed the APIs using request and response DTOs, added validation, implemented the service and repository layers, and used centralized exception handling for consistent error responses. For integration with another service, I added timeout handling, error handling, and structured logging with correlation IDs. I also wrote unit and integration tests and documented the API. As a result, the microservice was delivered successfully and integrated with the platform. The clear boundary and standard API design made it easier to maintain and extend layer. Common mistakes to avoid. 1. Saying only, I worked on microservices. Bad answer. I worked on microservices using Spring Boot. Better answer. Explain what service you worked on, what problem it solved, how it communicated with other services, and what you personally built. 2. Ignoring failure handling. Bad answer. One service called another service. Better answer. I added timeouts, retries for safe failures, fallback handling, and monitoring for downstream latency. 3. Not explaining service boundaries. Bad answer. We created a microservice. Better answer. We defined the service boundary around one business capability and avoided mixing unrelated responsibilities. 4. Forgetting observability. Bad answer. The APIs worked correctly. Better answer. I added structured logging, correlation IDs, metrics, and dashboards to support troubleshooting. 5. Ignoring data ownership. Bad answer. All services used the same database tables. Better answer. We clarified which service owned the data and avoided direct cross-service table updates. Best practices for answering this question. Key. Use the STAR method. Key. Explain the business problem. Key. Explain the microservice you worked on. Key. Mention service boundary. Key. Mention REST or Kafka communication. Key. Mention database ownership. Key. Mention validation and error handling. Key. Mention resilience patterns. Key. Mention security. Key. Mention monitoring and tracing, testing, and deployment. End with measurable impact. What interviewers are looking for. Interviewers want to see whether you understand. Check. Service boundaries. REST API communication, event-driven communication, database ownership, distributed system failures, retry and timeout handling, idempotency, monitoring and tracing, security, deployment pipelines, maintainability. For senior roles, they also want to see cut, architecture ownership, cut, microservice decomposition, cut, scalability thinking, cut, production readiness, cut, data consistency awareness, cut, trade-off analysis, cut, cross-team collaboration. Strong words to use in your answer. You can use words like designed, implemented, integrated, decoupled, secured, monitored, traced, deployed, validated, scaled, refactored, migrated, standardized. Example: I designed and implemented a Spring Boot microservice, defined clear service boundaries, integrated it with downstream services, added resilience patterns, secured the APIs, and monitored it using logs and correlation IDs. Good microservices topics you can use. Depending on your experience, you can talk about check, building a new Spring Boot microservice, REST communication between services, Kafka event-driven communication, monolith to microservice migration, service boundary design, database ownership, distributed tracing, service-to-service security, retry and timeout handling, circuit breaker pattern. Check. Dead letter Q, API gateway, CI/CD deployment, Docker containerization, Kubernetes deployment, monitoring and alerting, centralized logging. Final summary. Tell me about a time you worked on microservices is an important interview question for backend and Java developers. The best answer should include what microservice you worked on, why it was needed, your responsibility, service boundary, API or event design, database access, service communication, error handling, security, monitoring, testing, deployment, result. Good examples include CAP, building a Spring Boot microservice, Kafka-based communication, splitting a monolithic module, handling downstream service failure, improving database ownership, securing microservices, troubleshooting distributed systems, CI/CD deployment for microservices. The strongest answers show real backend experience, distributed system thinking, reliability, scalability, and production readiness.